over IP. Voice over IP is a new technology, but I think it became most common PABXs until the late 90s, or either the old analog PABXs or digital PABXs, but not voice over IP. So, of course, when you went to voice over IP, it means our networks design nowadays is just designing data networks, and which you end up carrying voice in the process. And what has happened is the same standards that they have maintained the telephony standards, uh, which have enabled us to be able to, uh, I mean, the early digital telephone standards, which has enabled us to continue using data networks or even interfacing the old systems with our data network, the old telephone system with our data networks. At the basic level, a computer network is just any collection of independent computers that communicate with one another over a shared network medium, which means we need to look at how they do it. That's why we come to the protocols. We have to look at what are our options or medium. Um, how do you connect more than one computer, because a network has to be at least two computers. We will see how you connect the computers. So you need some network devices to be able to do that. Um, so pass over network. Of course, you need at least two computers for you to call it a network. Then you need a network interface card. Yeah, a network interface card is very, very important because that is the one that gets you into the network. So it offers you the network interface, the physical interface. It also offers you the uh, functional interface. Yeah. So there is definitely a card to uh, access a network, and we call it the network interface card. Yeah. We are going to see later that it plays a very important part in a communication, a computer communication network. There is a network medium, which may be wired or wireless. Wired includes one of the most common wire you're going to see today, I mean cable you're going to see today, is a twisted pair. Then there is a coaxial cable, and there is the optical fiber cables. Those are the wired. Wireless, of course, wireless may be, it can mean infrared, it can mean which we use maybe for things like remotes. It could be Bluetooth, it could be Wi-Fi, it could be terrestrial microwave, it could be uh, satellite microwave. Yeah, but the most common one is the twisted pair, and specifically the unshielded twisted pair. Yeah. Yes. Yeah, unshielded twisted pair. UTP. U means unshielded. Does not mean untwisted. Unshielded. One thing is about computer communication. There's a lot of use of abbreviations. So those are some of the things that you need to understand, the terminologies, because if you are going to work with other people, terminologies become very, very important. You may understand, you may know what they're talking about from as a person who has done communication, but if you don't know the terms used in computer networking, then of course that can hinder your interaction with the other team members. So network device, this may be a hub or a switch, and of course two computers could be connected directly using a crossover twisted pair cable. Yeah, so if you're only having two computers, you don't need a switch or even a hub. Yeah, a hub and a switch, the difference is that a switch is intelligent while a hub is not. What we mean by intelligence is very simple. It means what a hub does, if it gets an input, yeah, if it gets an input, it is simply, uh, it gets a signal coming from a computer. What it will do, of course, this computer could be, for example, if it's Ethernet, one of the most uh, common layer 2 protocol, that will be clear what layer 2 protocols do when it comes to the OSI model. So if your computer, if you're using Ethernet, this will be maybe 100 meters. It can go to a maximum of 100 meters. And what happens after 100 meters? The signal is attenuated. So it will just be, what we are saying is by 100 meters, although it's attenuated, you can still recognize whether it was a 0 or a 1. Yeah, that's basically what we are saying. It is attenuated. Remember, we had talked about the the uh, the data being encoded. Actually, that encoding is done at the network interface card. The data is already encoded into a signal. Remember, this is the one with the network interface card, so to access the network. So it's encoded into a signal. That signal travels on this wire. By the time it reaches here, is a bit attenuated. And what happens is that signal has to be regenerated. It means actually it's a receiver. It receives, then it regenerates that signal afresh. It is able to identify that that was a 0 or a 1. And then it will send it to all the ports. Yeah. So other computers which are connected there will get it. Yeah. Because it is degenerated and sent to all the ports. A switch works differently. A switch will get the signal and since it is intelligent, and when we talk of an intelligent device, what we mean is it's able to detect, it's able to detect address, it's able to detect an address. It can read an address and it knows from the address I'm trying to think whether I need to talk about this now. I talk about it later. Maybe I should talk about it now, even as we proceed. In today's communication, I don't want to assume you have done it, or maybe we can just remind ourselves. Almost nearly all our telecommunication today use something we call packet communication, because that is the only thing you can do in digital. The meaning is in how the zeros and ones are organized. So when you organize them into a group, you call them a packet. Yeah. So the packet would have fields inside. So you have many bits. Actually, in a transmission, there will be a string of bits. And how do you get the bits? You get the bits by using an analog to digital computer, because I mean digital converter. Because remember, almost all our signals, the ones that you are going to deal with, are actually analog. If it is your voice, if it is a phenomenon, maybe it's from a sensor. Maybe you have sensed something. You have sensed it's a sensor of some sort. So it will be analog. But since we are dealing with a digital communication system, you have to convert that into digital. And I think we did it when we did entropy encoding. We did entropy encoding just early this semester. That is one of the encoding methods. Yeah. So your system is already digital. Now, how the system works is those bits are organized into packets. And I think already we have seen that when you are talking about error detection and correction, they are arranged into packets. In fact, the error correction and detection will just be one field of the packet. So the packet would have many fields. Yeah. So there will be one field which deals with error correction, another field which deals with the address, another field that deals with synchronization. Yeah. But there will just be actually groups of ones and zeros. Yeah. And it is that different arrangement of ones and zeros that gives the meaning into a field. Yeah. Why I'm talking about that is because we are saying now for the switch, it has to look at that packet. It doesn't look at zeros and ones. It looks at the packets. And of course, how it does that, what is happening? Oh, okay. And how it does that is that every device that receives the signals and convert them into data will be having a buffer where it is getting, because actually in the communication channel, I don't know whether you're able to imagine that. In the communication channels, bits are transmitted bit by bit. They're not transmitted, well, even when you say you have transmitted a packet, actually you're saying it is because you have transmitted the first bit. When you say I've transmitted a packet, it means I've transmitted the first bit here up to the last bit. But when they get into the wire, they get bit by bit. That bit is converted into a signal. Yeah. Of course, sometimes they may go 2 bits by 2 bits. For example, if you are using QPSK, where you are, so the signal itself is carrying 2 bits. So it goes bit by bit, and depending on your kind of encoding, signal encoding, where if it is baseband encoding, it will be either Manchester or whatever. If it is passband, you'll be talking about the ASK, BPSK, QPSK, QAM, 16 QAM, 256 QAM. Of course, when you use QAM, you'll be taking many bits at the same time. But those bits will be buffered. You have to buffer them until they make the packet. So you're getting bit by bit, and you have a buffer, some kind of memory, where you are receiving your bits, and when they become a packet, now you can interpret those fields. So it means also this hub would have that. It gets bits by bits until it is able to form a packet. It looks into the packet. Now you are talking about the switch, which I said is intelligent. So it looks into the packet, it checks the destination address of the packet, because among these fields there will be the destination address and in fact the destination address comes first, and there will be the source address. Yes, it needs source address because it has to acknowledge that packet. So it needs to know where that packet came from. So it will read the destination address and therefore only forward it to the port where the computer with this destination address is connected. So it means it has to actually keep a table, and actually a switch keeps a table to know that the address of the computer connected on, let's say this, you can name these ports, port A, port B, port C, port D, or 1 or 2. So the computer connected to port B has this address. For now, don't worry about the address, what address it is. We are going to see later that it could be a MAC address, which you call a physical address, or it could be an IP address. But actually, in this case, it is a physical address, which is also called the MAC address, medium access control address. Yeah. So there will be that. So it will forward the packet only there. It will not forward to these others. The beauty about that is it reduces collisions, because the moment in the hub, when you take the signal to all ports, and there are others trying to communicate, there will be a lot of collisions. Collisions just means the signals combining and producing another signal which will not be able to be interpreted by your device. Yeah. We are going to talk more about that, but I wanted you to get an overview so that as we are talking, you can be able to imagine how that is happening, because one of the biggest issues is understanding about coming from the packet, or rather relating the packet with what you have done with encoding. Yeah. So I hope nobody has a question so far. I hope so far so good. I think I should go to see more people in the layout. Yes, Samuel?
Yes, you've talked about avoiding collisions, and I was wondering if, for example, you usually have so many users of a certain, let me say, a channel or a certain frequency band. Generally, what technique is used to make sure that these users, when they are communicating, their signals don't interfere with others?
Oh, okay. In the general case whereby you are a communication channel, I think the thing is they don't interfere with each other because they are operating at different frequencies. In the case of just frequencies, but in this case, how you're reducing collisions is ensuring that that you don't get see why I'm posing is because I'm there is actually to explain that I need to get to another area because there is how you are avoiding collision here. But now what you're talking about is like maybe in an analysis system, how do you avoid collisions? Of course, collisions are avoided because you're operating at different frequencies. Yeah. But where are you accessing, you see, this is a collision being caused at the device. But where you're accessing a common medium, like a wire, that one is done by now another. There's a, I was not thinking we are going to look at that topic, but maybe you may end up looking at it briefly. There's what we call access methods, network access methods, where you're accessing. So those ones again employ different mechanisms to avoid collisions. Now, what we call the multiple access methods. Multiple access methods. So there are things like CSMA, collision sense, multiple access uh, with maybe collision detect, yeah, collision sense, multiple access with collision avoidance, yeah. That is a different topic. How you avoid now collision on the channel where you have a shared cable, yeah. And there is how you avoid collisions within these devices, you know, because you don't want this guy is trying to transmit, and this guy has already transmitted, and he is sending to every port in the case of the hub. So the probability of collision, actually, collisions will be there, and that's why we have things like errors. But what you are trying to reduce is the probability of collisions. So a switch minimizes collisions. In fact, you are going to see later that there are actually other devices that are used to minimize, not to remove collisions completely, to minimize. Because when collisions are too many, it means there will be too many errors. And when there are too many errors, because of retransmissions, then at the end of the day, you end up reducing your throughput, the throughput of the system. Yeah, because of just you are just retransmitting the same data. Yeah, so collisions are not completely avoided. Yeah, even in this switch, but you realize actually collisions can happen in so many places. They can happen in the medium, and I think that's the one you're talking about. That one is addressed by different methods. Yeah, these ones actually that's why they are called collision sense. I mean carrier sense. Sorry, I said collision sense. Carrier sense multiple access. So it means in the method, before you transmit, you have to sense whether there is a carrier on the line. Yeah, and they apply an algorithm. One of them, for example, will be once you want to transmit, check whether there is a carrier online. If there's no carrier, transmit. If there's a carrier, you wait for some time. The algorithm will be wait for some random time. Yeah, and then of course the collision. Oh, this is collision avoidance. Collision detection will mean if you detect a collision, what do you do? So that will be another algorithm. So that one is handled differently in the medium. Now we're just talking about here, where you are trying to connect multiple devices through a switch. Yeah, because for example, if you have a LAN, this is how you will be connected. Yeah, within a switch, so you can communicate with each other. But when you try to communicate to each other, you may end up having packets colliding. Now, the fact that you are sending the packet only where it is required reduces the probability of collision and therefore the probability of error, and eventually reducing bit error rate. Yeah. I hope I answered your question somewhere.
Yes, thank you.
Yeah. It gets a bit complex, especially because some of these things are handled in different topics. So that's a part of a computer. A purpose, okay. Oh, the parts. So there will be the network device. That's what you have seen, a switch or a hub. And then we said, of course, you can use a crossover cable. Yeah, because remember these are a four-wire circuit, so you need to. Uh, Usually, what it means is the port computer is differently configured from the port on the switch. It makes sense. Transmission here must go to transmit here must go to receive here, and transmit here must go to receive here. So it means the cable you use for this connection cannot work with two computers connected directly because the transmit has to go to receive and transmit here has to go to receive. So if you connect two computers, you would have to cross over the cable. That's what you're saying. You do crossover to step your cable. So network operating system, software, system software will be required. This could be Linux, some call it Linux, Microsoft Windows Server, but generally an operating system. And it may not be a dedicated operating system because sometimes people get confused. In a LAN, you only have the standard Windows. How do you communicate? Yes, you can. The standard Windows has got networking capability, yeah, but it's not a dedicated network operating software. Yeah, that's what it means. The purpose of computer networks enable sharing of files. Actually, I find people still share files, but nowadays people share files through email communication or WhatsApp. But we rarely people do they share files in the original sense. I mean, meaning of the word. People sharing files to see the hard disk. Even now, you can do it. Of course, you can enable sharing in your computers, but nowadays we rarely do it. Actually, that used to be the most common sharing of files, where you enable sharing and each of you can be able to see each other's hard disk and download hard disk from another. So sharing of files, of course, nowadays we do it differently. WhatsApp, uh, email. Can enable sharing of peripherals such as modems, printers. Yeah, I think we still do it today. We a company has only one modem, and you are sharing it from your computers to access the internet. You have you can have a network printer which is shared. You can also, of course, even share printers which are not network, so long as they are on your network. You can access them through another computer. But you can also have a network printer, which is a standalone network. It has got a network interface card. It is not connected to a computer. Email communication, I think that is, we have that one. I think I don't need to say much about. Enable sharing of internet connection. That's what you're saying. You can have a modem, you can have a router. All of you are connected to some ISP outside through that. Enable video conferencing. Now it's all over. Video conferencing used to be a big thing. It's everywhere. I mean, that's what Google Meet is, video conferencing. Uh, what we are using now is actually video conferencing. I can talk to you and you can talk to me. We are basically in a conference. Yeah. Enable data management for business operations. Very important. If you're in a network, you are able to access a database management system where you can be able to access your data, and somebody else on the same network can access the data. It can even be outside your network. It can be even an online database. It can be maybe even the company has um, maybe the company has an intranet. We are going to see when we come to classic computers has an intranet. That's a network using IP protocols, but belonging to a specific company. That's what we call an intranet. We'll be having an intranet. Maybe UN has an intranet connecting, and I actually think UN has an intranet. You are connecting different campuses. They can communicate like they are one network. So you can have an internet and databases in one of the campuses, but everybody in whole University of Nairobi can access that database. A database normally will be storing information, maybe stores information, it may be storing personnel information, it may be storing how much you have borrowed from the organization. It can be anything, yeah. But just a structured way of keeping data in one place. I'm sure you have done database management system somewhere along the way, yeah. Um, Classification, yeah, this one is good to know because there's a lot of, as I said, there's a lot of usage of acronyms. LANs, that's just a local area network. A LAN, yeah? A CAN. You don't hear much of the CAN, but you always hear about the LAN, local area network, because that's the most common type of a network. So classification can be based on geographical coverage. Yeah, it can be based on functional relationship. So if it's geographical coverage, that will be either a LAN, a CAN, MAN, metropolitan area network. From the naming, this of course, local area network would normally mean maybe one room, although even a building can also be considered a local area network. It's actually also a local area network. Campus area network would mean you have more than one building. Yeah. And why, of course, it's important because when you're dealing with a campus area network, you may start getting issues of the cabling getting maybe the building getting out of the range of a certain uh, network medium. For example, let's say you're using Cat6 cables, the twisted pair cable. It is normally able to go up to 100 meters. That's what's recommended by that particular standard. Yeah, Ethernet standard. It's able to go to 100 meters. Now, if you're talking about a campus area network, you start now going to distances which are more than 100 meters if you are connecting the network. So it means now you have to think about using other uh, mediums, different medium. So it has different consideration from a LAN. But now you talk about local area network. It would mean probably you are able to reach every place with your Ethernet cable. Yeah, we wrongly call it Ethernet cable because Ethernet can be wireless Ethernet. It can be a coaxial cable running Ethernet. But we normally call them Ethernet cables. What you mean is the twisted via cables. So you may be getting out of the range of twisted via cables. But in a LAN, you are within that range. CAN, you are getting. Metropolitan area network, of course, is now larger. And of course, you see, whenever you talk of CAN, very likely you are within your own area. Your network is in the place you own. That may not sound important until you begin going into bigger networks, like even CAN. When you have a campus and a network, the whole campus is ruled by one company, like University of Nairobi. When you begin getting to metropolitan area networks, big ones, now these ones are normally in control. The ones in control are maybe a city, yeah. But now you see, when you begin now running, for example, network mediums, communication channels, you don't control that area. So it means a few things. Even doing fiber becomes difficult. You need leeway. Yeah. Because metropolitan does not mean necessarily that it is owned by the metropolis, but it's just an area of coverage. So if you have a big company that has got offices in different places, and it wants to create a network larger than a campus area network, then of course you are going to have issues because you need things we call wheel leaves. You need a wheel leaf uh, to be able, for example, to run a cable in somebody's land or maybe along the road. Yeah. So it's normally a bigger area, so it becomes a bit complicated. Of course, it's not as big as the wide area network. This is something bigger than now the metropolitan. And definitely here now you begin getting issues of it means getting a connection to create a wide area network. You need to have connections that probably you not be able to communicate. I mean to connect unless uh, unless you in most cases to run a wide area network you need to have um, I'm looking for you need to use a carrier. Yeah, you need to use carriers. Nowadays you call them data carriers. Yes, you used to call them carriers. They carry data, they would carry voice across long distances. Nowadays there are many because there are guys who are running who have either installed fiber or some have not even installed their own fiber. What they have done is they have leased dark fibers from the fiber cable owners, yeah, and then they light the fiber, yeah. Whenever you talk of dark fiber, it means you're just hiring the fibers themselves, just like wires, just as you would hire just a wire or a road, just having just leasing fibers in a fiber cable, and then you are installing the terminal equipment. So some carriers will just be either owning the cables themselves, or they will be earning. They will be just earning part of the cables. Yeah. Others can be satellite carriers. Others combine different types of network medium, but actually most of them they will use a physical medium, then they will channelize that medium and list out channels. They will convert it into channels within the medium, and then they can list you one of the channels. Yeah. Others are not even don't even list channels. They will carry your packets. Yeah. Now they will carry your packets in their network along with other packets. Yeah. So those will be packet carriers. Yeah. So whenever you get to the wide area network, it's normally, at least this one you can say it's within the control of the metropolis. So they don't have a problem of running fiber along the metropolis. But when you get now to the wide area network, and the widest of that wide area network is the internet. That's the biggest network. Yeah. So then there is a functional relationship. Yeah. Uh, and of course, here you are going to have a lot of you might hear, we might not do that ourselves. You might hear of the frame relay network. Yeah. Those are wide area technologies. You might hear of the MPLS. Yeah. Multi-packet label switching. You might hear of ATM, asynchronous transfer mode. Yeah, those are, you might hear of the X25. These are actually some of the old one technologies. Frame relay is still in use, but nowadays we are tending towards MPLS and ATM. But that's a different ballgame altogether. I don't think you'll get to that, especially because you have only 4 weeks. But I thought it's good as I mentioned them, so that when you hear them, at least you can see you've had them mentioned somewhere, and or you can dig more about them on your own. Yeah. So of course, the next can be classification based on functional relationship. That's where you hear about the client server network or peer to peer network. Of course, client server will mean you have got two computers. One is a client, one is a server. The client is usually a less powerful computer. It's not, sometimes it can be so less powerful that you are not able to do much on the computer itself. And therefore, when it is that, when you can't do much on that, we call it a thin client. Yeah, you can have a thin client, but generally, client is a less powerful computer that is relying more on the server. Most of the computation is done on the server, which is a much more powerful computer. Uh, it would mean probably it has more storage, it has more RAM. In most cases, it also has faster RAM. It will be using some different type of RAM, faster RAM. It means probably it has multiple processors. Yeah. You see nowadays on our computers, we normally have things like multi-threading. But when you talk to the server now, you go to another level. Apart from things like multi-threading, you have a multi-processing. So you have multiple processors. Uh, it could have uh, uh, things like hot um, hot swapping. It means you can remove hard disks from the computer. Hot swapping can apply to hard disks. It can apply to the power supplies. Yeah. So Generate means you can remove devices from that server when it is still connected. That's what you call hot swapping. You can swap devices when it's still connected. In most cases, it is the power supplies. You can so it will be having maybe one server connected to the sorry, I had what's happening now? Yeah. I hope you can hear me. I had lost you for a moment. Yeah. So functional relationship. So client server. So as I said, powerful to be more powerful, it would have those kind of facilities like post swapping and all that. Then you can have peer to peer. Peer to peer means all the computers and most LANs are actually peer to peer. It means one at one time one computer may be acting as a client and the other one may be acting as a server. Because normally the word server is a misconception because the word server people take server to mean the hardware. But server really refers to the part of the software that serves the other one. But now the one which the computer that is carrying the server software is the one which is called the server. Yeah. So every most softwares have got the client part and the server part. For example, email. Email you will have uh, at the server you'd have POP, post office protocol. At the client you'll be having STMP, simple SMTP, simple mail transfer protocol. Yeah. Or IMAP. Yeah. So the server is the one which is carrying the server software. So normally it will be more powerful because it's serving the others. Yeah. And then you don't want it to go off. That's why you have a power standby, multiple power supply so it doesn't go off. Yeah. It can also be based on topology. So you're going to hear about star topology. We are going to see what is star, mass topology, new topology. I think we can look at that when we reach there. So classification, so lands, these are the different uh, geographical areas, maybe a single building. This one is spanning multiple lands, probably a university, and this would be a city, but it's almost smaller than a one. We have others, PANs. This is a computer. These are personal area networks, PDAs, telephones, computers. These can be PANs. SAN, storage area networks, where we have um, where we are storing a lot of data. We may end up having a storage area network. It means it will be high-speed disks uh, connected. Probably you have more than one rack of disks as they are interconnected by fiber. Yeah, so those will be storage area networks. WLAN, like what you have, Wi-Fi, the one you could be using now. If right now I'm on Wi-Fi, it just means a wireless alarm, just alarm that is employing wireless instead of hardwired. And you have a one, so these ones we would look at the wide data technologies, but this is covering a big area. Yeah. So, and of course, it is characterized by much slower speeds for obvious reasons. Because if you are leasing uh, capacity from a carrier, the capacity costs money. So um, uh, you find that that's a major limitation of communication, the money factor. I mean, you want that's why you even to get your internet, you pay so much money just because of um, this person you are leasing from is also leasing uh, uh, one capacity. He's also leasing from carriers, so he has to charge you a lot of money. Yeah, or he has run his own uh, fiber network and he has to get back his. So the moment you're going to lease, you're not running your own cables, then the cost becomes an issue. So even in the design, one protocols are designed, one protocols are designed to work with low speeds. Yeah. So one connectivity can be achieved through a combination of this dial-up. I think we no longer do dial-up. I don't know if we're doing dial-up. Dedicated leased phone lines also not very common nowadays. During the days of telephony, this was one of the most common one. Satellite links, I think we are doing it now. Uh, for I think for many years we were using uh, geo satellites. I think now we have gone to LEO, the low Earth orbit satellites, like the one by uh, the Tesla guy. What's his name? I think he has. I think I think it is there in Kenya. I think it came to Kenya sometimes last year. Yeah, using LEO. Uh, Data packet carriers. Telecom Kenya is one of them. But there are many. It's just one of them. I think the Jambo Telecom, uh, even Safaricom. You can lease from Safaricom. Uh, it can be VPN, virtual private networks. This one you don't lease any connection. All you need is you have two routers which are VPN capable and they are connected by the internet. Of course, the only difference, you see, you can have the two computers where you lease a link. Okay, normally whenever you talk of this, you're talking about maybe these themselves are networks. Yeah, it's not one computer. Yeah. You can have that, and then of course you have a router. Put this network is different from this network, then you have a router. Okay, I've just put them together like this, but you'll be having, if you have more than one, you don't have multiple ports on a router. So probably you'll be going through a switch and then a router. To avoid confusion, let me just, I can call this a switch and then this a router. Yeah. So you have a router, here you have a router and a switch, and then this is connected to different. Of course, you can have that, what you call a point link. Yeah. But you can also have that you don't have this connection here. This guy is just connected to the internet, and this guy is connected to the internet. Now, the communication in the VPN is we call it tunneling. Yeah. So because like you're creating a tunnel in the network, you're creating a tunnel between these two networks. So you'll be having protocols that do tunneling. You don't have a direct connection, so you just need an internet connection. To work with the VPN, you need both sides to be connected to the internet, and then you can configure if your routers are VPN capable. You can configure your routers so that they see each other. These are very common arrangements. But you find nowadays, actually, what most people do is instead of creating your own VPN, there are guys who create VPN and now they can list you channels on the VPN. Yeah, they can channelize their VPN to. I will give you that, but you don't need them. Once you're connected to the internet, you can create a VPN if you have VPN capable routers. Yeah. Um, or it can be nowadays fiber optics. Yeah. But right now, the internet is connected through fiber. That's why you don't have delays nowadays as you used to have in the past. I think I talked about this during introduction. The internet, we know what the internet is. The intranet this is a private network utilizing internet protocols. It's basically an IP network belonging to a single organization. An extranet is the same private network, but you have allowed access from outside of an organization. Today, these things look obvious, but they used to be a big deal. Yeah. So VPN, or we have said we use these protocols. These are the various tunneling protocols. PPTP, point-to-point tunneling protocol, layer 2 tunneling protocol, and now there is OpenVPN. These are different tunneling protocols. It is used by very many organizations which have got offices in different parts of the world and create a VPN so that your offices maybe in Atlanta or wherever they are or in the UK will be working like they are in a LAN. Yeah. Then functional relationship, that is straightforward. I talked about it. Peer-to-peer, client server. Then the next one is and if you find there's something you're not clear about, please ask questions. Because I'm just going through it so that we can go to the OSI model. Yeah. So classification based on network topology, I think I've already, yeah. So this one, the most common is the star topology, where they're arranged in a star fashion. And of course, you can see the obvious advantage is that with star, you can remove and put back this computer without affecting the network. Yeah. And also when there's a problem, it is easy to troubleshoot. Because if it's not working, you know either it's the computer itself or the card or the wire or this port here. So long as the others are working, you can isolate that problem. Or it simply be a configuration issue. Maybe it's not properly configured, the computer. Yeah. So for example, if you have a network like this one, you can try to use something like ping. You can try to ping this computer, and if you don't get it, you know that computer is one having the problem. Yeah. So the others you can ping. So The problem is here and not the switch. Yeah. So that is star topology. Of course, it means advantages. If this device dies, you guys can communicate. Yeah. So that is one of the ring topology. That is the ring topology. This one, it is used well. It used to be used by IBM. IBM had come up with token ring protocol. We don't use much nowadays. We use Ethernet. That's what I use. So this token ring protocol was using computers connected in a ring fashion. Yeah, it had its own advantages. Yeah. So this token ring is actually standardized by IEEE. Of course, Ethernet is IEEE 8. If you can't remember this, don't worry. 802.3, that is wired Ethernet or wireless Ethernet. 802.11. If you can't remember, there are things you remember. Once you work with them for a long time, you can remember. So those are some of the. So, but what we are saying is this particular one works. Computers are connected in this fashion. Yeah, and communication is normally in one direction. And in the communication to in the computer, you have to go through the next computer. It's sequential. So if you are sending a packet from here, if this is computer A, B, C, D, E, F, G, H. If A is sending a computer to H, a packet to H, it cannot come this way. It has to go around. But what is important about this uh, system that works with this topology is that to send the packets, you need to have something we call a token. And that token is only one in the system. So if you don't have the token, you can't transmit. Of course, it ensures that a few things that you cannot have two people transmitting. So there are no collisions in this system. Yeah. So advantage of new topology reduces collision as nodes transmit only when they are allocated the token. This system only works with token ring. And let's not mistake I mean ring topology. That's a topology. Token ring is a layer 2 protocol. Is yeah, but the ring topology works with that layer 2 protocol called token ring. That's why we are mentioning it here, that there are no collisions because of the fact that you can only transmit. Okay, don't get confused. So there is token ring, that is this topology by IEEE. There is also what you call token passing. Token passing is an access method, and ring topology is a topology they use. Yeah. So this process is called token passing, which is used by token ring, which is arranged in a ring topology. Those terminology can be a bit confusing, but I think they will become clear as we go on. That is if you haven't done it before. By the way, maybe I could be making a wrong assumption. Eric, uh, Eric Ogola, I think what I've heard from you people is you did introduction to computers. Did you touch uh, what I'm talking about, the basic networking, because sometimes it has a topic on basic networking. Even if you don't do computer networks, introduction to computers itself does have a topic in that. And in most of that, people do either the OSI or they do a small introduction to the computers. Or so, Bola, is this new or you have come across it in?
I think we had come across it sometimes back, mm, last year or something. Yeah.
Or when you're doing computer networks, or um, when you're doing introduction to computers or computing
Introduction,
for engineers, eh?
introduction,
Or introduction.
yeah, introduction to computers. Yeah.
Ah, Ochoro even came across it in uh, high school computer studies. Ah, very good, very good. So I just hope that most of you had that chance. But then I'll not feel guilty if I move a bit fast. Because sometimes when I move a bit fast and I assume somebody has not done it, it can be a bit daunting. So there is a token, and each computer has equal resources to. So these are the advantages. Disadvantages, of course, it is slower. And obviously, it is slower. Since you have to go through every computer for the packet to reach where it's supposed to go, of course, it's a bit slower. And of course, if one station goes down, the whole network fails. Yeah. Bus topology, this one, this one normally works with the coaxial cable. This is a coaxial cable. Coaxial cable is like the one you use your TV. It has got um, two conductors, one center conductor and an outer conductor, which is usually just braided wires, just braided wires, which act both as EMI shield and a conductor. Yeah. So that uh, is a very easy topology. It used to be used a lot when we are using coax, which we don't use nowadays much. We don't actually use it with the networks because of the speed limitation. Coax used to go up to 10 megabits per second. So you don't use it nowadays. Yeah. But it is easy to connect, adding a computer. You require less cables. See, it's just one cable running. You don't have different cables. You can just have your cable running just near where the computers are, so at least just a short wire. Yeah. The way it is connected, this is a T connector. So it goes through and also comes this way, another T connector. These are T connectors. These are terminators. They actually loads terminators so that you remove the possibility of having a standing wave just uh, moving between here and there will be no communication. Yeah. Disadvantage, of course, if there is a break here, the whole network is dead. Doesn't matter what which in any, but of course you can create two networks by simply terminating here and terminating here. Yeah. This becomes a complete network again. It becomes a complete network. Those the terminators, any disconnection somewhere will kill that network. And then it's very difficult to identify problems if the network shuts down. And this one I'm talking from experience. When I started working, I did meet this network, and whenever a cable has failed, it was virtually impossible FEE522, it was virtually impossible to know where it has failed, because the moment it gets a disconnection anywhere, even here, the whole network dies. So how do you troubleshoot? So you don't know where it is. It can be here, it can be here, it can be here, it can be here. It was very difficult to trace a network in this cable. I mean, a fault in this cable. Yeah. It can be anywhere along this cable. And you can imagine this is a big office with 100 computers connected to one cable. Yeah. It can be. So that's one of the biggest problem of this. And of course, it requires terminators. Mesh. This is one of the most common in the network. I mean, in the internet. In the internet, for example, your routers are connected in what we call a partial mesh. Partial means like this is a partial mesh, because every computer is not connected to every computer. This one is connected to these three, and this one is connected to these three. So this is a partial one. But if you have, for example, that's a full mesh. This is connected to the three, this is connected to the three, this is connected to the three, but these are full mesh, partial mesh. Yeah. The advantage of this is because they are self-healing. Because of self-healing means, for example, when this is used with routers, the routers will just look for an alternate route. Yeah. If one route fails, it gets another route. So we call it self-healing. So you, as a user, you may never notice that connection has gone, because it has gotten another connection. So your communication will continue. Yeah. It's expensive and complex. Yeah. You can imagine the moment you have so many, this multiplicity of parts, then it becomes complex. This is another topology, like the token, ring topology is another ring topology. The only difference between this ring topology is that this one is using fiber as the communication. I know that I'm not even doing it here. It looks like this. It is using fiber, and it's also a double ring. It's a double ring, and one goes in different direction. This is what we call FDDI, fiber distributed data interface. Okay, it specifies 100 megabits token passing over dual, is what we call it, dual ring, using fiber optics. Of course, nowadays 100 megabits per second is very small, but when this FDDI was introduced, that is the time we are talking about a token ring was being 16, because this token, remember, this is using token passing. Token passing that time was working with about 16 megabits per second. I think even IBM abandoned it, who are the original, they were, who came up with it, they abandoned it and they abandoned token ring and went to Ethernet also. Yeah. So advantage of this include high capacity, redundant circuit, long distance, because of course you're talking about fiber, it can go long distance. but of course it's expensive compared to other topologies. And by the way, we still do have this. We still do connect fiber in this fashion, but it's not the original HDI. So that if, for example, you have got offices in Nakuru, offices in Nyeri, offices in Kajiado, and some maybe in Machakos, you can connect fiber in this fashion so that you never, your company will never be out of communication. Of course, it will be expensive to have that kind of thing, but that means there is always an alternative route from one. So here is where you have your LAN. You have your LAN connected here. You have your LANs connected. I'm doing like this because I'm assuming this is a switch. These are device which will be having maybe routing capabilities. Or maybe it's just connect directly to the switch. But this will be an FDDI device. This will be just a standard switch. Yeah. So this may be your LANs, and they are connected like in this fashion. We still have this kind of ring connectivity over the networks. Domain systems, I'm sure you have heard this term before, because computers work with zeros and ones. So our IP addresses will be zeros and ones. But as human beings, we are more comfortable with names. Yeah, because we call each other names. Yeah, literally speaking. Yeah, so there has to be a way of converting an IP address to a name. For example, if your network address, I don't know what is the network address of Nairobi University, but if you assume, let's say, is I don't know, I'm just thinking maybe 172. I'm assuming it's a class, would be normally a class B network. 172 dot. By the way, this is purely random. I don't know. Although of course I can find out from the internet what is the IP for Nairobi. Uh, dot one. Sorry. Forgive me for that. Dot zero. Dot zero. I don't know whether you have covered IP addressing, but I'm assuming Nairobi University has been allocated a Class B block. If I go to Class 4 addressing, Class B block. A Class B block would mean this is 00, so this will be a Class B block. Yeah, this number is here. So maybe you allocated that, and so this is 00. But what happens is, instead of, if you go to the internet, actually, it's interesting. If you go to the internet and type that address, it will take you to the University of Nairobi still. Not this address, the address that represents that. But what do? I think the name we have is UONBI dot AC dot KE. And then, of course, you may have now another name, which is maybe engineering dot uon dot nbi, dot unbi dot ac dot k. I don't know whether there is such a one, but there could be that one, which now takes us to IP addresses now here within this one. Now, which will be But this is a whole network address for UON. Now it will have those other addresses, yeah, that go to specific places, yeah. So normally we have that DNS, and of course, is this what you're saying is hierarchical? This is a hierarchy. Even this is always a hierarchy.ac.ke. .ke, this is hierarchical. You see, there is KE, there is AC, there is UNBI, there is ENG. That's what you are calling hierarchical. So KE brings you to Kenya. So whenever somebody sends a packet, it does not begin searching where is UON. It will just come to KE. And once you reach KE, your packets will look for academics, AC, and then go to UNBI. Yeah. So of course what it means, we have Ismail. Yeah, your microphone is on, Ismail. So you can, so of course you have databases everywhere. You have DNS servers, domain name servers, and they are everywhere. Oh, Ismail, your microphone. Yeah, thank you. So you have DNS servers, of course, which have got a DNS database, which is basically lookup tables, names, and their corresponding IP addresses. Network standards. These are the network standards you might have come across them. ISO. These are the guys who came up with the they came up with the OSI model in networking. They came up with the OSI model for network management, and this is called FCAPS model. This IEEE, they are the owners of all those technologies. Yeah, 802.3, 802 this, 802. They have many others, but the one we interact most of it is this 802 series. Yeah. EIA, we also have it. It was electrical. I think before we used to have EIA in America, in the US, they came up with a TIA, more specific for telecommunications. So you are going to find some very many standards have got EIA stroke TIA, because before there used to be EIA. Then when telecommunication industries had their own standards, they were just converted to TIA. One of the most common ones, of course, is 5, 6, 8, A and B. Yeah. So these ones talk about the network interface. So you find one, maybe you arrange wires in a particular way. Yeah, the one you use most is B. Yeah. I'm trying to wonder whether it's I get into that now. Maybe I can get just into that when you talk about networking, the network medium. Yeah. Especially with Cat5, Cat6 with UTP. Yeah. But so these are the different standards, organizations. Then there is the ITU-T, is the communication side part of ITU. Of course, they are both telecommunication, but whenever you talk of ITU-T, you are talking about aspects of ITU that are not wireless. Other is we have ITU R. So ITUR just deals with radio, and ITUT deals with the rest of the telecommunication sector. Yeah. So if you're dealing with radio, everything like satellite, that would be under ITUR. Other things would be under ITUT. Yeah. Network protocols. This is what we are going to look at. We are going to look at the protocol architecture. So protocols, of course, define how computers communicate, how it is communicated, and where it is communicated, when it is communicated. So, and these are common data network, data communication technologies. Data communication, conveyance of information from source to destination. What is data? Symbolic presentation of information, zeros and ones. We call it symbolic, 0 or 1. Signals represent the data in a data communication system. So you have to do signal encoding. You have to do encoding, or you have to do data encoding, sorry. So you convert data into signal, which now you transmit. Bit, the basic unit of information, 0 or 1. Bitrate, bits conveyed per unit time. Baud rate is symbols conveyed per unit time. Why it is different? Because you can have a signal communicating more than 1 bit. So the rate, signal rate, is called baud rate. Baud was a gentleman who came up with that. Yeah. So any question on what we have done? That's small introduction we have done. It took longer than I thought. It has taken 1 hour 40 minutes. We still have 1 hour 20 minutes. So yes, Samuel.
Yes, I have a question and a request. The question is,
Yeah.
The switches and the hubs, can they perform the kind of error correction you were talking about earlier in the semester?
Oh, error correction. Yes. That, I'm trying to think in which device that, yes. That would be in the switch. Yes. That, I'm trying to think exactly where it would be. Whether you need to correct it at the switch level or you need to correct it at the equipment level. If, for example, yes, there is some error correction which can be done. In fact, you can't do error correction at the switch. Yeah. What you can do at the switch is error detection. Yeah. That happens at the switch because what happens between nodes, you're going to have, you can have error detection. You don't normally have error correction between nodes because these are switches. These nodes can be switches or hubs. Yeah. So you can detect errors here, and when there's an error, you ask this guy to transmit. In fact, normally, if there's an error, you don't need to ask because if there's an error, it means maybe you are not even sure whether the channel is working. How it works is this guy has to send the information he does not get an acknowledgement. So yes, that one happens at the switch level, but I think it will become clearer when we go to OSI model. The error correction happens at the end station, the the end station, yeah? This one at the end. This was happening. This is this in between the communication, you know? This one is communicating this. So error correction happens here. And why am I saying it happens here? Because it happens in a layer which we call TCP transport layer. This will become very obvious when you come to the OSI model. It happens as a transport layer. And transport layer, these don't have transport layer. These have only 3 layers. Transport layer is layer 4. Yeah. So correction does not happen in these devices. It happens in at the end stations, not these nodes in between. But detection, yes. Correction, no. Okay, your second question. Did I answer the first question?
Yes, thank you.
Yes. You have
Yeah,
the second one.
the second one is more of a request. We have lab at electronics lab at 10 a.m. and personally I didn't have enough time to be at school at that time when it starts. So I was kind of requesting if you could spare a few minutes so that we can get there in time. It's at 10.
Oh, it's at 10. So what we'll do is we can we end 10 minutes earlier? Because now it's just 9. Is that okay? Would that do for you?
Yes,
Or you
yes,
wanted to
maybe 20.
20? Because I'm sure some of you are already at the university. Maybe for those who are not at the university, can leave a bit earlier. I'll allow you to leave earlier, no problem. But I can continue probably with those who are at the university. Another question, somebody has a question, Cherry?
No, I'm okay.
Oh, you're okay. Very good. Very good. Very good. So let's go to this OSI model. I'm sure you have had the OSI model either in high school or maybe the introduction. Is one of the most important. This network protocol architecture. I call them network protocol architecture, but actually they're just network models. But mainly it is talks about protocols at different areas. So what is it? The protocol architecture is a layered structure of hardware and software and supports exchange of data between systems and supports distributed applications. That's a standard Google. If you Google the internet, that's definitely you're going to get. So at each layer of a protocol architecture, one or more common protocols are implemented in communication systems. I think it will become clear what protocols are. Each protocol provides a set of rules of exchange of data between systems. There has to be rules. That is, when you receive this, it means this. That's what a protocol is. When you receive, when maybe a certain protocol will be saying, if you receive this, it means this. But a different protocol, by this I mean bits. If you receive this bits arranged this way, it means this. But in another protocol, that could mean something different. Yeah. Because remember, in digital communication, the information is in how the bits are arranged. Yeah. That's where the information is. That's what carries the information. So we have, what is the advantage of this layered architecture? Because remember, this is a standardized layered architecture. So standardization has its own advantages, and of course, layering has also some advantages. Yeah, so the layered helps us break the network communication into smaller and simpler parts. What we are saying For example, we are going to find out. I've noticed it there. You're going to find out that oh yeah, you're going to find that we are going to look at one of the models we are going to look. Actually, we only look at one model in this case. These notes have given you cover many models, but I want to look at only this OSI model. But the other one, we won't look at it because it is basically almost identical. Yeah, except that it has fewer layers. So the model we are going to look at has 7 layers. I've not reached there, but I will talk about it because to help us understand something. So, and we say a switch is a layer 2 device. So switching activities happen in this layer 2. The layers go from 1 to 7. Yeah. A router is a layer 3 device. So what we are saying, and then there are some things which are done here in these layers, the transport layer, which do not have to be included in the router. So router does not have to have functionality which happen here. Yeah. The switch does not have to have layer 3 functionality. Of course, we have some switches we call layer 3 switches, but those are specifically built to have that functionality. Yeah. So what we are saying is it simplifies when you reduce the operation of a device to a particular layer. So instead of having one big device that does all that, you can have different devices. So you have a switch, which when you need to do routing, you connect it to a router. Yeah. When you want to do error correction, of course, it means you have to have these other layers, which are only available at the end-to-end systems. Yeah. And we are going to see when we come to the ISO layer model, what we mean by end-to-end systems. Then why is this standardized? Of course, it allows multi-vendor development and support. So because it's standardized, these layers are standardized. It means Cisco can make their switch in layer 2 and it is able to interface with a router belonging to D-Link because of the standardization. So you don't have, for example, to have your equipment is coming from one manufacturer. Yeah, you can have from multiple vendors. Yeah. Then it allows for different hardware and software to communicate with each other. It allows interoperability. Not only is it possible to do multi-vendor development, it's also possible to have equipment from different vendors being able to communicate each other. Software from each vendors, from different vendors, being able to communicate with each other because of standardization. So the two most common architectures are the OSI model and the TCP/IP model. So this one has been standardized as a learning model. The OSI model is by ISO, and TCP/IP model. This is a node model. That's very interesting because this is the beginning where the internet started. Because this model is also called the internet model. Internet model, DoD model. I think I talked about it in the introduction. That is the Department of Defense, because a department, I think it's a sub-department. Yeah, I think it was called ARPA. Is it ARPA? ARPA. I don't know whether it's advanced research something, but it needs to belong to ARPA. That's the spelling. Oh, there's Yes, I'll save the letter and remember which things I'm missing. This belongs to DOD because there used to be the ARPANET. Yeah. So it was a department of the DOD that was doing that, one that developed the internet. So we call it the internet model, the DOD model. This is a 4-layer model, this is a 7-layer model. And we will start by looking at this model. So this is the model. Very easy to remember. I think um, we used to have, I think I talked about this during the introduction. Yeah. So these are the 7 layers. These 6 plus the physical. This one, physical layer. And we are going to look at what happens at each layer, the 7 layers. So this is layer 7, and this is layer 1. They don't go the other way around. We start with the physical layer, which is layer 1, to application layer, which is layer 7. Then there are some terminologies here we need to get familiar with, and that is protocol data unit. Whenever you talk about PDU, we are talking about the PDU at a specific layer, the protocol data unit. It will be the smallest unit of data in the protocol of a given layer. Because remember, we said the meaning is in the arrangement of the bits. So we are saying what is the smallest protocol data unit in a particular layer. And in various layers here, we just call them packets. From layer 7 to layer 6 to layer 5. But then we come to this layer, layer 4, we call it a segment because you do segmentation in that layer. Layer 3, sometimes we call it packet, and sometimes we call it datagram. But however, sometimes we avoid the term datagram because datagram seems to imply that you are using user datagram protocol in layer 4. Yeah, we are going to see this layer 4 protocols. So sometimes we just call it packet, and of course layer 2 we call it a frame. Yeah, I think this will become very clear as we go on. Then, of course, what happens is at each layer we add a header. As you come from the upper layer, going down, you add a header. Now, the header is one that the header is actually like metadata, It tells you about what is inside the packet. So if you get a header, if you get a packet from, let's say, you get data from the user. This is the data from the user. When you come to the application layer, you are going to add an application header. If you are wondering what application header does, it will even be saying which protocol. For example, suppose you are transmitting something between here and here. So this side is the client and this side is the server. What will happen at this end, it will give you, for example, the client protocol. Like, for example, if it is email, it will tell you it is STMP, not SMTP, simple mail transfer protocol. So simple mail transfer protocol will be part of this header. So there may be other things in the header, but among those headers, it is just communicating to this guy at the end. I am using simple mail transfer protocol so that he can understand that this particular user is using a simple mail transfer protocol. Yeah, you get it. It is meant for communicating between the layers. Yeah. And why we say communicating between the layers? Because it will come down like that, but at the end of the day, it will end up here. So you're communicating to this person. In fact, I think the best way to see it is if two people are communicating, and let's look at the old method which we used to use, the post office protocol, which we still use today. The post office meant because you'd go and post your letter to the post office, and then the post office guy would pick it and drop it to the guy at the other end. But the information you have put there has no meaning to the post office guy who is transporting your data. In fact, it has only meaning to the person you are sending to, because your data will be encapsulated. You start the first encapsulation, of course, you put it in an envelope, and some guy takes it. Either take it yourself to the post office, then post office will put it in another bigger envelope. Yeah. And that bigger envelope will be put in a vehicle. Then the vehicle will take it to somewhere. Then it will be decapsulated. You remove it from the envelope, the vehicle. Remove it from the bigger envelope. Then remove the up to a small envelope and drop it to somebody. So that data has only meaning to the person at the end. And that's how the same way our communication works. So there are so many things you're going to lose with the data. But at the end of the day, that data is communicating to the guy at the other end. So you're going to, so why I was talking about this is because after this, now this is the application. But when it comes to presentation, you're going to, now when it comes here, you're going to add another header called presentation header. This again will be telling this other end that these are the protocols, presentation protocols we are using. Yeah. Now, what happens is at this layer, oh, okay, at this layer, this is called a PDU. So this is the PDU for layer 6. This is a PDU for layer 6. Yeah. Then this is the SDU for layer 6. Service data unit. SDU for layer 6. But this SDU is a PDU for layer 7. So what you call it depends on at what layer, because this part is a service data unit to this PDU at layer 6, but itself is a PDU for layer 7. So we normally say the SDU for layer N is a PDU for layer N plus 1, because N plus 1 is going up. Yeah. So that this PDU and SDU is something you can bring confusion, but that's what it means. So SDU at any layer N is the PDU of the layer above it, N plus 1. I hope that context of PDU and SDU has come clear, because the term which is used a lot, especially the PDU, so it's good to understand what that PDU means. So the PDU for at layer 4 is called a segment, packet, a frame. Yeah. So here we are, application layer followed by presentation, session, transport, network, data link. And you can see from here that Intermediate nodes don't have transport layer. They only have these three layers. So you find, and and then these layers, these four layers are called end to end layers. End to end layers. Because they only apply to the end. They are not going to be found in this part, which sometimes we call communication subnet. This part, which has only we call it the communication subnet, they are not going to be found in the communication subnet. So these are end-to-end layers. They are meant to communicate this end. Here, this communicates to the adjacent guy. Yeah, the adjacent guy, and but here only end to end. So as I said from the beginning, you can remember your layers by all people. That is a what I used to call it, a rhyme, or all people seem to need data communication. Yeah. Ah, not data communication, sir. That data processing, not communication. Just how you're remembering. Yeah. But otherwise, you don't even need to remember. Once you deal with them, then they become, with time, you don't even need to try to remember it once you understand it. So, application, yeah, that's layer 7. Do you continue, or do you need a small break? Do you need a 5-minute break? 3 hours is a long time. Or we just continue?
A 5 minutes break is fine.
5 minutes break. So let's meet at 9:10. It's 9:04. Let's meet at 9:10. That is I think we have had enough break. So the application layer, that is layer 7. This is the one that provides users in a nutshell and application processes access to network services. This is the entry point to the network. So functions here include resource sharing. So any protocol that deals with resource sharing will be in this layer. Remote file access,